Bismillah ar-Rahman ar-Rahim. The last part we spoke about the vector dot product A dot B, and we said that A dot B is like just multiplication component wise. A1 with B1 plus A2, B2 plus A3 times B3, and we will get scalar value. Today we are going to speak about the cross or vector product. The cross product of two vectors is just a vector. The output for the cross product will be a vector. Of two vectors A and B given by A1, A2, and A3, and B given by B1, B2, B3 is a vector. Given by or is the vector. A B, which is equal to A2 B3 minus A3 B2 I plus or minus. So the second one is minus A1 B3 minus A3 B1 J plus A1 B2 minus A2 B1. Okay. So this is the cross product of the vectors A and B. And sometimes you are using the determinant of a matrix, or you can say A cross B is just the determinant of the matrix I, J, and K, with this A1, A2, A3, and B1, B2, B3. This is the definition of the cross product of two vectors A cross B. It is a vector. We have to keep this in our mind that the cross product is a vector, but the dot product is scalar value. For example, let's find A cross B. For A, first one, A is given by 4I plus J minus 5K. And B is equal to 2I plus 3J plus K. We need to find the cross product. So A cross B, using the notation of the You see the determinant. A1 is equal to 4. A2 is 1, and A3 is minus 5. 4, 1, minus 5. For the B, it is 2, 3, and 1. Now to find the determinant for this one, using the idea of the determinant, I will take the first one, that will be I. Just to make it easier. Then we cross the row and the column, the first column and the first row. What I have now is 1 multiplied by 1 minus 3 times minus 5. So this is 1. Let me use. This is 1 multiplied by 1 minus 3 times minus 5. This is for the first one. The second one is minus. Because for the determinant, we are using cofactor or of the matrix, that will be, the first sign will give me plus, second one is minus, and the third one is a plus. The sign is alternating for the determinant. So the second one is minus. Now for the second one, we take this out, and it will be J. Now we are using J. So cross the row that include J and the column. So they have 4, 1. So in this case, 4 times 1 minus 2 times minus 5. So this is 4 times 1 minus 2 times minus 5. 4K. Let me take this out now and use the K. That will be plus sign. For K. So cross this one or cancel the row, and the column contains the K. What remaining will be 4 times 3 minus 2 times 1. It is 4 multiplied by 3 minus 2 times 1. So we will have now, this is 1 plus 15i minus 4 times 1 is 4 plus 10 j plus 4 times 3 is 12 minus 2 k. So I will have 16i minus 14j plus 10k. So this is the vector A cross B. (16i minus 14j plus 10k). If you go back for the formula, A2 times B3, that's for A, A2 B3 minus A3 times B2. That if we are using this formula, or just use the determinant, we're using the principle of the determinant to find the cross product. Another example, B. Suppose that A is given by 2, 2 minus 4, and B is minus 3, 6. And I need to find A cross B. Is I, J, and K. A1 is 2, A2 is 2, A3 is minus 4, B1 is minus 3, B2 is minus 3, and B3 is 6. So this is equal to I minus J plus K. For the first one, I, this one, cross the first row and first column. Then I will have 2 multiplied by 6 is 12. Minus 3 with minus 4 will give me plus 12. This is 12 minus 12. 4J. Let's go for the second one. J, this one. Cross the first column and, first row and second column. I will have 2 multiplied by 6. That will give me 12. Minus 3 with minus 4 is 12. 4K. Third one is K. So cancel the first row and third column. 2 minus 3 multiplied by 2 minus 3 is minus 6. Minus 3 times 2 is minus 6. I will have now 2 minus 12, or 12 minus 12 is 0I. Minus 12 minus 12 is minus 0J. And minus 6 plus 6 is 0K. So this is 0 vector. A cross B equal to 0. We'll come to this later on. If we have cross product of 2 vectors equal to 0, we call them parallel. A cross B are parallel. If the, we can write this down. If A cross B equal to 0 for non-zero vectors, then we say these are parallel vector. Are parallel. Parallel. If A cross B equal to 0 for non-zero vectors A and B, then we say they are parallel. Let's take third example now. Number 3. A equal to 3I. B equal to minus 2J. Then the cross product A B equal to, this is I, J, and K. A1 is 3, A2 is 0, and A3 is 0. For B, A1 is 0, or B1 is 0, B2 is minus 2, and B3 is equal to 0. So the cross product for this one, for I minus J plus K. This one, 0 times 0, 0 plus 2. Sorry, 0, this is not 0, plus 0, yeah, or minus 0. For the second one, J cross this one and this one. 3 times 0 is 0 minus 0. For K, of this one with this one, 3 minus 2 is minus 6 minus 0. So the answer for this one will give me only minus 6K. So let me write one remark in this point. I cross J will give me K. J cross K equal to I. K cross I will give me J. It's like this. We have like a circle. I, J, and K. I cross J will give me K. J cross K will give me I. K cross I equal to J. If we reverse the direction, we'll have negative sign. That will be number 4. It's reverse. J cross I will give me minus K. K cross J is minus I. And I cross K is 4, 5, 6. That will be minus K. So for the cross product, this is the idea of finding the cross between two vectors A and B. I'm going to finish this lecture by just stating the properties for cross product. First one, A cross B equal to 0 if A equal to 0 or B equal to 0. But this is not if and only statement. Let's just say that if the cross product equal to 0, it means A equal to 0 or B equal to 0. But in some cases, we have A cross B equal to 0 for non-zero vectors when they are parallel. So this is just one direction, A cross B equal to 0, if A equal to 0 or B equal to 0, but this is not if and only if statement. Number 2, A cross B equal the negative B cross A. Reversing the order of the vector will give me negative sign. So we have to be careful about the order of the cross product. A cross B is not equal to B cross A. This is different from the dot product. For the dot product, A dot B equal to B dot A, but for the cross product, it is not. Number 3, A cross B plus C equal to A cross B plus A cross C. Number 4, A cross A is equal to 0. A cross A is equal to 0. Number 5, A dot A cross B equal to 0. For this one, A dot A cross or A cross B, we'll explain this in later on to see that the result of the cross product is a normal vector or orthogonal to both of them, A and B. A dot A cross B, this one, the output of A cross B will be orthogonal vector to A and B. So by the same way, by the same idea, B dot A cross B is equal to 0. So this means A cross B is orthogonal to both vectors. A and B. This is the meaning. A dot A cross B equal to 0 and B dot A cross B equal to 0. It means that the vector A cross B is a normal or orthogonal to the both vectors A and B. So this will be the end for this lecture or for this part. Later on, we are going to give more examples about these properties and more features about the cross multiplication or a cross product of the two vectors.